transforming the graph y equals x squared. So a transformation is moving something to a different position but having the same size and shape. And when we translate, we're moving without rotating or flipping, horizontally or vertically. So we're going to go through some manipulations of a graph and show different kinds of transformations. So if we look to our graph to the right, this is a graph of y equals x squared. And we know this because if we took a table of values for x squared, and these are x and these are y, if we did 1, 2, 3, 4, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. On the graph, 1 and 1 goes here, 2 goes all the way up to 4. So we know that this is what a quadratic looks like, a parabola. And it's the plane x squared. So what we're going to do now is we're going to add and subtract things to x squared to see how it manipulates the graph. So on your paper, it says to draw the graph of y equals x squared. Just do a rough sketch. This is what your graph should look like. For the next one, if you take x squared plus 1, if you type this into your graphing calculator, you should get something that looks like this. So as you can see, the graph of x squared plus 1 has been moved, and it's been moved one place up. So when we draw this on here, we need to just change that it's been moved up 1. If you check your second one, x squared plus 3, you can see that it's moved up 3 spots, so it's up here. What you might notice now is that whatever this value is added onto the x squared is going to change whether it goes up or down. And we'll test that by checking the last one. When you type this into your calculator, it moves 2 down. So when you're transforming y equals x squared plus q, we know that it is a vertical translation. And it's of q units. So however much that q is that you're adding on, that's how many units you're going down. Also, we know that this is going to be congruent to x squared. And this is because the shape and the size of the quadratic isn't changing. It's just moving position. So if you were to pick that parabola up and move it back to the vertex, it would fit right on top of it again. So it's congruent. For the graph, y equals x plus 2. So now we're not adding 2 on the outside, it's on the inside of the brackets. So if you type that into your calculator, make sure you use the brackets. You should get something that looks like this. So what you notice is that it's moved 2 to the left. So we're going to draw that in, 2 to the left. If you take the quadratic x minus 2 and type it into your calculator, you should notice that now it's moving 2 to the right. So if you were to take a guess where the last one would go, it's going to move 3 to the left. So if you look at this transformation, we know that it's going to be a horizontal translation because it's moving left and right. If you look at this minus p, we know that it's going to be opposite of whatever sign it is. So that doesn't mean that it's not p. If you had a negative 2, that would turn into a plus 2. Your p is still negative. So we're still moving p units. But just remember that it's opposite direction. Than what it shows in the brackets. This one is also congruent to y equals x squared. For the next one, this time we're manipulating by multiplying x by something. So just for a thought, if we took the x value 1, if we plugged 1 into x squared, 1 squared is 1, so our y value would be 1. If we plugged it into our second equation, 1 squared is 1 times 2 is 2. In our third equation, it would be 1 and 3, 1 and 0.5, 1 and negative 1, and 1 and negative 2. As you can see, our x values are not being affected whatsoever, but our y values are being multiplied. So that means that they're being stretched and compressed. Stretching means it's going to get bigger because you're multiplying bigger, like this one, this one, this one, this one, and this one. It's a bigger value. And compressing means a lower value, so this one. So if we were to graph these, let's first graph y equals x squared. So we know it goes through the points 1 and 1 and 2 and 4. So our parabola looks like this. If we graph our second equation, we know it goes through this point here, 1, 2. So our parabola is going to look something like this. On your paper, you should label these. I don't really have a lot of room doing it on the iPad. Okay. As you can see, it gets narrower the bigger the value in front of x is. So this one is going to go through this point here, so it's going to go even narrower still. The vertex does not change though. It all still begins to start at 0, 0. Now, point 5. Point 5 is right here. So this time, instead of getting narrower, it's getting wider. When we go negative, it's still going to go past 1 through the same points as the x squared, but negative this time. So this is our y equals negative x squared. And 2 is going to be the same as our original one, except negative as well. So these are all of our different graphs that we just manipulated. They're all still based off of y equals x squared, but they've been stretched and compressed vertically. So for our transformation, y equals ax squared, when a is greater than 1, so anything bigger than 1, it's going to be stretched vertically. From a less than 1, it's going to be reflected across the x-axis. And from 0 to 1, anything between 0 and 1, it's going to be compressed vertically, because it's all of our y values that are changing. Those are the ones that are being stretched and compressed. So for the last thing, we want to find the direction, the vertex, the symmetry, and if it's congruent. So A, it is opening up, because we know that this is positive in front. It's going to be translated horizontally because it's inside the brackets, and it's going to be 5 units to the right. So our vertex has to change 5 units to the right, x-wise, so our vertex turns into 5, 0. Axis of symmetry is equal to our x value, and this will be congruent to y equals x squared. For B, we know it's opening up because it's positive. It's going to be translated vertically, and it's going to be 3 units up. So our vertex isn't going to change our x, but this time it changes our y. Our axis of symmetry is equal to 0, and it will still be congruent. And for the last one, it's going to open down because it's a negative. It's going to be stretched by 2, and it's going to reflect. So our vertex isn't going to change because we know that vertex don't change on this transformation. X will equal 0, and this time it is not congruent.